All right, so summative number 10 in Algebra 2. This should be our last summative, at least our regular summative. We still have our final exams and post-tests to do, but celebration time. All right, so let's make sure we get our good scores in so we don't have to do any retakes. This first section is the first and only time you're probably going to get a chance in class to take this, so make sure you remember how to complete the square twice for circles to write them in standard form. So remember, standard form for a circle is x minus h quantity squared, and then plus y minus k quantity squared, and then it equals, I'm running out of room, it equals radius squared, so r squared. So remember what was unique about the circle formula, because both x and y were in group, oops, I forgot a squared there, because they were both in groupings with quantities being squared, there's a built-in negative sign for both the h and the k this time, so we have to remember to do opposites. This is the way you guys always remember it for both h and k. So first, if you have two colors, use them. You're going to group your x's together and write x squared minus 30x, and then we're going to complete the square on the x's. Plus, we're going to do something similar for the y's. We're going to group our y's together. So y squared plus 28y, and then you're going to complete his square. Now this 417 is like basically just in the way. So we're going to move it to the other side of the equation by subtracting it. Why is that blue? I don't know. Let's make that black. So we have a negative 417. And then you're going to add the blue blank. And then obviously add the green blank as well. Oh my gosh, what's wrong with my colors today? There we go. Now, clearly, I'm going to run out of room to do number 2, which I wasn't planning on doing anyways, because I'm going to do all the odds with you, I think. Alright, so for the blank, remember it's half of your b term, so take this middle number, take half of it, so negative 15, and then square it. Negative 15 squared is positive 225. And then for 28, if you cut that in half, it'd be 14. 14 squared is 196. And the reason you completed the square is because now you should be able to write both of these quadratics in their factored form. So you're going to steal the variable x and then half of this middle term including the sign. So minus 15 quantity squared plus, same thing over here, you're going to steal the variable y and then half of this middle term including the sign. So plus 14 quantity squared. Oops. And then remember that's a negative 416. Oh my gosh, black. That's a negative 417. Oh man, it's Monday morning and I can't add, so I have a feeling it comes out to like 1 or something. Let's see. Negative 417 plus 225 plus 196 is 4. Alright, 4. So now you're not done because they do want you to identify. Oh, they don't ask for it here, but just get in the habit of identifying center and radius because we're going to have to do that on the next step. The center is located at, remember, opposite signs for both. So the center is located at positive 15, negative 14. And the radius is the square root of this last number when it's in the formula. So the square root of 4, meaning it's a 2. So using those skills again on number 3, you're going to complete the square twice, and then we're going to actually go further and identify the center and radius for sure, and then we're going to graph it. So, grouping the x's, that would be x squared minus 2x plus something. And then we're going to do the same thing for the y's. Y squared plus 6y plus something equals, that 6 is really in the way, so we're going to subtract it over here. And then, of course, you're going to add the blue and the green blank on this side as well. Alright, so for the blue blank, half of negative 2 is negative 1. Negative 1 squared is positive 1. Make sure when you're squaring, if you're using your calculator, that the squared symbol is outside of the parentheses, or just remember that this blank, because you're squaring a number, is always going to be a positive number for these. And then 6 cut in half is 3. 3 squared is 9. So all this blue work here, that was so we could write it as a quantity, steal the variable x, and then cut that middle number in half, minus 1 quantity squared, plus, same thing with the y's, steal the variable, and then cut that middle number in half, plus 3 quantity squared, and then I should be able to add this one, huh? 10 plus negative 6 is a 4 again. Well, that's kind of boring. Alright, so your center is located at +1, -3, opposite signs for both factors. And the radius length is the square root of 4, which again is a 2. So when I go to graph this, I plot my point for the center at 1, -3. And then you go up 2 and down 2, right 2 and left 2. And then you hope for the best, because you can't draw a circle. Oh, is that just me? You know what? That was almost really good. I didn't even use my cheater pen there. Alright, so number 4 is very similar. Alright, this section, this is your second opportunity, and we've been hitting this pretty hard in class. We're going to make sure that we know how to simplify and complete operations with complex numbers. So the first task that you're going to have to do is simplify the square root of 75. So remember when you're breaking down radicals, you try to break it into 3 radicals. Sometimes you don't need all 3 of them. But the important part is -1 should go in the middle. That would be good simplification. And then your perfect square goes in the first radical. And then anything that is left over will go over here. So things that didn't break down into perfect squares. So 75 is not a perfect square, but it does have a perfect square factor in it. So let's pull the -1 out and throw it in the middle radical. And now let's just talk about the number 75. Well, 75 is the same thing as 25 times 3. So 25 is the perfect square in that set, and 3 is our leftover. So now it's just a job of simplifying. I know that the square root of 25 is just a 5. I know that the square root of -1 is just an I. And then the square root of 3 doesn't simplify at all, so we just leave it. Alright, oh, some of you had a very bad moment when you took the test last time and then you were handed it back and you like did a face palm. You're just supposed to add the complex numbers here on number 7 and 8. So complex numbers, when you're adding them, you can only add the like numbers. So you're going to add your real parts, which are -5 plus -3, so that's -8. And then you're going to look at the imaginary parts, so -8i plus -4i. You can say plus -12i, but most people just write -12i. So yeah, those should be really easy questions, where you're just adding and then next time we're subtracting. Just watch your subtraction order. So subtracting our real parts this time. 2 minus a -2 is a 4. Type that on your calculator if you don't believe me, but it is a 4. And then we're going to do the similar process here for the i's. 3i minus -5i. 3 minus -5 is really a positive 8i. So our rule is when you're simplifying or performing operations with complex numbers, you never stop until your answer looks like this. Now the positives and negatives can switch, but you should have a real part and then an imaginary part typically. You shouldn't have anything extra beyond that. Sometimes the real parts cancel or the imaginary parts cancel, but not always. And I don't think I set it up on your test for any of that to happen. Alright, so this next question here, you are multiplying everything together. So when you multiply, it doesn't matter what type of number it is. So 7 times -8 is a -56. And then 7 times -3i is -21i. And then you got to keep going with the next set of numbers. -2i times -8 is a positive, 16i. And then this last one is usually where kids mess up. You have -2i times -3i, which is a positive 6, and then I times I will become I squared. Now that's a far cry from our, remember, a plus bi form. So you got to keep working until you get that form. So one thing you notice is the middle term here, the i's are going to collect together. So you have a -56, and then you have a, I should be able to add, -5i. And then the other thing we have to remember is I squared is something special. I squared is the same thing as -1. So this problem really says plus 6 times -1. So this really says a -6 on the end. And again, we're still not done because you can add the -56 and the -6 together. And you get negative, I should be able to do that, huh? -62 minus 5i. Now, that does look like a plus bi form, so I feel like we did something great. Alright, let's look at number 13. 13. Okay. You know what? For funsies, I'm going to go over here and do 14 because I'm going to run out of room otherwise. So I'm going to look at my denominator. And on your test, I think it's already got parentheses around it, but make sure that if it doesn't, you put parentheses around it. And I need to use what's called the complex conjugate to the denominator. So the conjugate is that vocab term I need from you. So the conjugate to negative 7 plus 2i is, it's still negative 7, but you're going to change the sign on the I part, so now it's a minus 2i. And then of course you can't just multiply the denominator of a fraction, you have to also multiply the numerator of a fraction. So, in the numerator, you have a multiplication problem, and in the denominator, you have another multiplication problem. So your job is to make this better by simplifying by distributing. So multiply an I into here and here, and you get negative 7i, and then a minus 2i squared, over, the denominator is a little more complicated. They are conjugates, so you're going to see some nice things happen. But you still need to think about what happens when you FOIL all this out. So negative 7 times negative 7 is a positive 49. And then you have a negative 7 times negative 2i, so that's plus 14i. And then in the middle here you have a minus 14i. And yes, those do cancel, because they should. They're conjugates. 2i times negative 2i is a negative 4i squared. Alright, so this doesn't look a thing like that. So you gotta have to keep working at it. So remember, I squared is negative 1. So let's use a black pen so we can see that a little better. I squared right here and I squared right here are both going to switch out for negative 1. And then, yeah, these do cancel here in the middle. So right now I'm looking at negative 7i, and then negative 2 times negative 1 is really a plus 2. And then down here, this 49 is still here, but then a negative 4 times negative 1, this is going to become a plus 4. So if you were to combine those together, you'd get a 53. And actually, if you guys got to that step, I'd probably give you a 5 and not worry about you not quite simplifying to a plus bi form. But I would like you to think about, okay, this 53 is being divided under each part of the numerator. And then I'd also to realize that it's kind of backwards. So the best answer is 2 over 53. That's the real part. Oops, not plus. And then it's minus 7 over 53i. That's the I part, the imaginary part of the complex number. So this is the best answer, but frankly, guys, if you got down to that version, I'll be happy with that. Alright, this is a new thing. We're solving radical equations, but you're going to have to show me fluency with both methods that we learned. And what's kind of cool, because you're solving the same problem, if you happen to forget that there's an extraneous solution when you do the algebraic one, you're going to catch your mistake on the graphing one. So that's kind of the purpose of this question. So I, personally, like to do the algebraic one first, just because I like algebra. And my graphs are always terrible. We all know that. So I know we're going to square both sides here. The left side, easy peasy lemon squeezy, the square root and the square just cancel each other out and you get x plus 2. But on the right side here, we have to remember that this is x minus 4 times another x minus 4. So it's not as simple as just, quote, squaring things. So x plus 2, that was the easy side. This other side we got to work. So you have, oh my gosh, my pen's not going to work. No, no, no. It's going to be hard to write. All right, here we go. X times x is x squared. X times negative 4 is negative 4x. And then you have another negative 4x. And then negative 4 times negative 4 is a plus 16. So we have a quadratic, which means we need to move everything to one side. I'm going to choose to move everything to the right side. So I'm going to subtract the x, and I'm going to kind of place it under here with all these other x's. I'm also going to subtract this 2, and I'm going to place it underneath the 16 with the other constant. So in our quadratic, we have 0 equals x squared, but then you got to collect all of these middle terms together. Negative 4x minus x is negative 9x. And then a plus 14. So every time I give you one of these, they should come out to really nice factoring questions. So while you could solve these with different methods, I might lead you towards factoring, guys. So we have x minus 7 and x minus 2. Those would multiply to positive 14, and they would add up to a negative 9. But you're not done, because now you need to solve each factor. Yes, they are easy to solve. So x minus 7 equals 0, so x equals 7. And x minus 2 equals 0, so x equals 2. But you're not done. And if you don't catch this part, you're going to catch it on the next part of the question, luckily. But remember, we're always supposed to check our algebra questions for what we call extraneous solutions. So if you were to go back and check x equals 7, you would plug in an x equals 7. So square root of 7 plus 2, is that the same thing as 7 minus 4? Well, that's the square root of 9. Does that equal 3? Yes, it does. But look what happens when you check the other solution. So you get the square root of 2 plus 2. Is that the same thing as 2 minus 4? So is the square root of 4 the same thing as negative 2? And the answer to this question is no, it is not. So this answer of negative 2, or sorry, of 2, come on, this guy right here is actually extraneous. So the only solution that works is x equals 7. But here's the great news. Because I'm going to make you graph it as well, you would have figured that out because these are the same questions. There's a different approach, a different method. So what you're going to do is you're going to, if you're not sure what this looks like, you could use your calculator. You could type this into y1, and then you could type this one into y2. And our beautiful color screen calculators will show you that you'll have a square root graph shifted over to the left 2 units, and you would just steal some points off of your table. Let's see, 0, 2, 4, 2, alright. And then, let's see, 7, 3, oh my gosh, I can't graph. And you do want to do an accurate job of graphing, oh man. And then y equals x minus 4, that is a line that starts at negative 4, right? This is the same thing as mx plus b form. So it starts at negative 4 on the y-axis, and then it has a slope of 1. So up 1, right 1, up 1, right 1, and then of course I can't graph really well, so I'm going to kind of cheat. I already know it crosses here. So that's the point, guys. The solution is where your functions intersect. And I know this is the ordered pair 7, 3, but the actual solution, remember, was for you to find x. So the solution is x equals 7. So because these were the same question, just different approaches, you should get the same answer. So when you solved it algebraically and you forgot to check, whoopsies, and then you went to go solve it by graphing and you went, oh snap, there's only one solution, you would then go back and cross off x equals 2, understanding that it never checked out because it's extraneous. I like that. I think it's a really nice question. So there's another one for you to try. Oh boy, they're back. Exponent rules. And not just any exponent rules, but rational exponent rules. So I'm going to stick to, I'm going to do every other question again. And first thing I would do on these questions is I would rewrite it with multiplication dots in between each term, because I think sometimes kids get a little confused on where to start. And just rewriting the question sometimes really helps. So the other thing I might do is, if you had other y's to collect, you might put a 1 on the y right here just so you know that there is an exponent. Okay, first issue we have to tackle is what to do with the 12 over 18. Remember, these are coefficients. Coefficients are not exponents. So if you just had the fraction 12 over 18 and you were asked to simplify that expression, you would divide 12 over 18 and reduce it. So if you're doing this by hand, they both divide by 6. So it becomes 2 over 3. But for most of my kids, they just are really tired at this point on the test, so they just math enter this on their calculator and reduce it to 2 over 3. But, we got to get ready for the SAT as well, guys, so maybe think about using your calculator a little less than you normally might. Here, the rule is, now we do have exponents, and when you're dividing the bases, you're supposed to subtract the exponents. So, 5/3 minus 1/2, there is no shame in you guys using your calculator to subtract those on a test. But, it's a Monday morning and I'm feeling like a challenge. So what I would do is you'd have to get common denominators. Again, you are under no obligation to do these by hand. So this fraction is really 10 over 6, and this fraction is really 3 over 6 with common denominators, which means 10 over 6 minus 3 over 6 is 7 over 6. And then there's no other terms to go with this single y that's already down in the denominator, so I'm just going to leave it there. And that's actually your final answer, because the rule is you're not done until there are no parentheses, and then the other rule is all bases combined. And then the third rule is you can't have any negative exponents, because a negative exponent means the term has to move. So keep that in mind. Alright, I'm going to skip 17. I'm going to move on to number 18. Again, I'm going to start by kind of putting multiplication dots in between each of them because I think that helps me. So this time, I'm looking at my coefficients, which are 11 over 2. And I'm going to try to reduce them, and it turns out I'm not going to have a lot of luck because 11 over 2 doesn't reduce. So my coefficients are still going to stay as 11 divided by 2. Don't put 4 point, what would that be, 5.5. Don't put 5.5, I want a fraction coefficient. And surely don't subtract those because those are not exponents. But this time, you do have bases with exponents, so these are ones where you're going to subtract. 2 minus 1/3, so again, if you're doing these by hand, you'd have to get common denominators, which means you'd have to multiply this dude by 3. So that's 6 over 3 minus 1 over 3, which means my new exponent for the y is, I don't know why that's black, blue, 5 over 3. So there's no exponents, there's no bases to combine, there's no, there's no parentheses, there's no bases to combine, and there's no negative exponents, so that's our final answer. That was 18. Alright, let's take a look at, please do try the ones that I'm skipping, especially since some of you really need a good score on this one. Alright, number 20. Oh boy. So again, you could put multiplication dots in between all these. There's only one dot though, right? Those are the two terms. So when you have an exponent outside of something like this, and some of you know exactly what to do with this particular exponent, what you need to think about is an exponent outside of parentheses like this needs to be distributed to every term in the multiplication problems. And those that already have existing exponents, you multiply them together. So we're distributing and we're multiplying. Okay, I apologize. I don't know what happened to my formatting, but this thing was supposed to be over here in number 23. So, whoopsies on that. Alright, so my work, I'm going to throw it down here. You have 4 to the negative first power times y to the 6 to the negative first power. We're supposed to multiply those together, and we get a negative 6. And then x to the, again, we multiply these together, so the negative 3/2 power. Oh my gosh, but golly, come on, pen. So, good news is we got rid of the parentheses, so that was nice. Bad news is we are not done because I notice we have a slew of negative exponents. Anything that's negative, basically it needs to move. So anything with a negative exponent moves, so that's going to move down, and so basically everything moves. Alright, so up in my numerator now, we have x to the now positive 3/2 power. And then down in the denominator, you have a 4 to the first, you can just call it 4, and then times y to the now positive 6 power. All my bases are combined. That's a great answer. Leave it like that. And then 22. Again, we have an existing exponent outside of the parentheses. It needs to be distributed to all my terms. And there's multiplication dots in between all those, remember. So we're distributing a 1/2 power here, and there, and there. Oh my gosh, that made it really ugly. Sorry. So you have 49 to the 1/2 power. We'll come back to that in a second. And then you have x to the 18 times 1/2 will become x to the 9th power. And then 36 to the 1/2 power times y to the 3rd power. 6 times 1/2 would be y to the 3rd. Alright, so we are technically not done according to your math teacher simplification rules because this is something. And if you don't know what it is, try typing it on your calculator. 49 to the 1/2 power is the same thing as taking the square root of 49. And then, so same thing here. This is like taking the square root of 36. So, my final answers here, my coefficients simplify really nicely to a 7 over 6. And then x to the 9th power can stay where it is. There's no other x's. And then y to the 3rd power can stay where it is. There's no other y's, and there's no negative exponents. Man, life is good. That section is done. And that will be the conclusion of your test. Now, what you're going to notice is after we finish this test, we're going to start prepping for our post-test. And you're going to also notice that a lot of these questions are questions that are very heavily inspired by what's on your post-test. So not only are we going to get some new scores in our grade book and help us out, we're also studying for our post-test at the same time. So good luck, everybody. Final test. Celebrate.